Hola, bienvenidos al canal del audio. Hoy te muestro un video de cómo hacer un micrófono casero. Antes, te invito a suscribirte y si este video te fue de utilidad, dame un like. El video que te voy a mostrar no lo hice yo, pero quedé asombrado al verlo. Vamos a ver cómo se construye un micrófono casero y vas a quedar asombrado con el look y el sonido que produce.
In this video, we're going to be building a fully DIY microphone that not only has an incredibly unique retro aesthetic, but is entirely self-contained, featuring a built-in shock mount, adjustable boom arm, preamp, and a USB Type-C interface.
El micrófono que se va a construir tiene ya el preamplificador de micrófono y el convertidor analógico digital, es decir, no vas a necesitar de una interfaz de audio para poder grabar en tu computadora.
Cheap microphones are readily available in the devices we use every day, but their sound quality leaves a lot to be desired when it comes to anything other than communication, partly due to the limitations posed by the physical size of their microphone capsules.
Este detalle es importante. El tamaño del diafragma del micrófono va a influir en la calidad del sonido,
which are generally far smaller than those used in professional equipment. Remarkably though, some of these large capsules aren't actually that expensive, and it's possible to buy the exact same capsule that's in this $500 microphone, for example, for just $12 directly from the manufacturer, which is a huge saving if we can process the signal as well as the original circuitry does.
Y el detalle que yo no sabía es que puedes comprar las cápsulas directo al fabricante por una fracción de lo que cuesta el micrófono.
This particular capsule is a JLI 2555 and is a permanently polarized type, which makes it fairly easy to get a sound signal from it, simplifying the build process quite significantly. Because the membranes in microphones of this type have such a weak output though, this output needs to be strengthened before anything can be done with it. On a lot of small capsules, this extra strength is provided by an internal transistor soldered to a PCB on the back. But the much larger JLI microphone leaves it up to the designer to add one, presumably for customizability. Thankfully, suitable transistors are readily available, and hooking it up just requires the leg labelled as gate on the datasheet to be soldered to the capsule's central tab like so. The leg next to it won't be used, so I just chopped it off to avoid confusion, leaving the remaining legs known as drain and source. Because of the way the transistor will work in the circuit, I'm going to refer to these legs as microphone positive and microphone negative, as they'll both be outputting the same signal but at opposing phases, which will be handy for the preamp circuit we'll be building later. Now, as the goal is to isolate the capsule from desk noises, a normal audio cable is just not going to cut it for wiring these legs up, as even thin varieties are far too stiff and allow vibrations to be transferred straight into the capsule and become very audible.
Esto ocurre frecuentemente en los micrófonos lavalier, en donde el cable empieza a inducir ruido en la cápsula. Fíjate que la prueba que él hace, cuando toca este cable, puedes escuchar cómo el diafragma se activa.
A solution to this is to actually make a custom cable using some thin enamelled copper wire like that used in the windings of small electric motors. With the mass of this wire being so low, vibrations just won't be able to travel through it, and being enamelled it means that short circuits are prevented if they ever touch each other. However, as they are bare wires, they're still vulnerable to electrical interference. With the normal audio cable, this interference is dealt with by an outer shield of copper strands that wrap around the middle two cores, preventing interference from affecting them, and a great way of replicating this functionality is to use some 2mm desoldering wire. Now, you might think that the only use for this stuff is to enable the removal of solder from bad joints, but taking a close look at it reveals that it's in fact braided in such a way that allows it to be opened out with something like a knitting stick, which returns the braid to its original pre-squashed hollow shape. This means that the delicate enamelled wires can be pulled back through it, resulting in a fully shielded 2-core microphone cable that should block pretty much all vibrations from travelling down its length due to its extremely low mass.
Esta es una solución muy inteligente, ya que estás creando un escudo contra la inducción magnética, es decir, estás protegiendo estos pequeños cables de interferencias.
Once the enamel has been sanded from the ends of the thin wires, they can be soldered up to the remaining legs on the transistor, with the shield itself going to the capsule's ground tab. After making sure that they're both connected properly, the polarity needs to be marked, making it easy to join them up to some normal audio cable, with the red wire being for the positive signal and the white wire being for the negative signal, and heat shrink protecting all of the joints. So, with the cable now sorted, you might think that it's ready to test out on something, but not so fast. Just like unshielded cables, a large diaphragm capsule will pick up a lot of interference from the surrounding environment, rendering its output unusable. This is why microphones always feature a dense metal mesh around their capsules, as it blocks all interference while allowing sound waves to pass right through unobstructed.
Esto es interesante. La rejilla que protege la cápsula no solo es decorativa o de protección.
To start off our version of this, we're going to begin with some brass wire mesh, which is thin enough to be cut through with scissors. After drilling a hole of similar size to the microphone capsule in some wood, this mesh can be shaped by hammering a suitably sized cylinder or dowel down on top. This is an easy way to make some really nice custom shaped grills that match the capsule, and we need one for both the front and back. To join these together, we'll need a thin brass strip, which needs to be made into a ring that the grills can fit into. The reason why we're using brass here is because, besides looking really nice, it can be soldered too, allowing for easy welds in a home environment. While it is possible to solder these together using a reasonably powerful soldering iron, another alternative is to use a small kitchen blowtorch, as these are super cheap and work quite well for jobs like this, as you'll see in a moment. So, after polishing it up with some wet and dry sandpaper followed by some metal polish, the join is barely noticeable. But before the capsule and grills can be mounted to it, some hooks are required for the suspension system. I found that a good way to make these is to bend some brass wire into small loop shapes and then solder them to the ring directly with some flux and solder. Although this time using a torch from behind is recommended, as it makes no physical contact, so minimises the chances of knocking it out of position. After giving this a final polish, the capsule and grills can be pushed inside and held in place with some epoxy. Though it's worth noting that they all need to make electrical contact so that they work as a grounded shield around the capsule. All of this effort is definitely worth it in my book, as it looks great, with a real retro charm to it. But there is one serious flaw in its design. It's not immediately obvious, but after testing I found that having the brass cylinder extend back as far as it does affects the audio pickup in quite a significant way.
Esto es importante. Recuerda que el micrófono escucha por delante y por detrás. Y la forma de desfasar el audio es retrasándolo a través de estos huecos, y adicionalmente que la distancia que tiene que recorrer el sonido es diferente desde la parte de adelante y atrás.
You see, the capsule we're using is designed to be highly directional and only pick up sounds from in front of it. The way this works is to actually allow sound waves to enter in at the rear of the capsule through many small holes that are precisely sized and positioned to cause a delay in the sound as it enters here, resulting in the cancellation of sounds from off-axis. Because the cylinder interferes with this delay, the cancellation effect is reduced and the microphone picks up a lot more off-axis sound, which in some cases will be desirable, but for vocal use, not so much.
Al tapar la parte de atrás de la cápsula se modificó el diseño inicial, es decir, se alteró la sonoridad de la cápsula.
Thankfully, remedying this is fairly straightforward, as drilling plenty of holes along one edge of the initial brass strip, as well as making it as shallow as possible, allows the sound to enter in at the rear unimpeded, so it leaves intact the capsule's directional pickup ability, and in my opinion it looks even cooler in appearance thanks to all of these holes. So, with the capsule encased and wired up like this, it's time to make the all-important arm and suspension system for it. Brass is again ideal here, only this time we'll be using it in the form of 3mm rods, which can be bought from places like Amazon and eBay. Links in the description below.
En la descripción del video te dejo los links de todos los materiales que él utilizó para construir el micrófono.
As the ends of these are a bit rough when cut, using a file to round them off is a good idea, especially when followed up with a drill and wet and dry sandpaper, as a highly polished finish can be achieved. Their job is to provide support from which to suspend the microphone from, and I'm bending mine slightly for aesthetic purposes, after which some more brass wire can be used to make the anchor points, similarly to what we did on the capsule. They do need to be securely held apart though, so the remaining rods can be bent into arches and leant over to meet in the middle, which allows them to be soldered together with a short brass tube. More about this in a moment. After soldering the side pieces to the ends of these larger arches as well, you can see that it makes for a really nice sweeping shape, and it's fairly structural as it's essentially two curved triangles. Before the microphone can be suspended from it though, it does need a support arm. Keeping with the brass theme, some brass tubes are needed this time, along with a brass rod that can fit snugly inside them.
El sistema de suspensión de un micrófono o el shock mount va a prevenir que la cápsula detecte vibraciones provenientes del brazo o del stand.
This brass rod is fairly critical, as shorter lengths of it can be cut off to make some internal end caps that can be soldered in place to one end of each tube. This makes the ends solid enough for some through holes, particularly as the surrounding area needs to be filed flat. This flatness allows the tubes to be clamped together using a screw to make a hinge, and as the main structure remains hollow, it will allow the microphone's grey wire to be routed through them later. To function properly though, this support arm needs another hinge at the bottom as well, which can simply be made by giving some more brass rod cut-offs the same filing and polishing process that we used earlier and clamping them in place with a few bent pieces of brass. The main arm can be slid down on top of these like a sleeve and held in place with some more screws. And just like that, we have a fully articulating arm and cradle system. But before it can be assembled together with the microphone suspended from it, we need to work on the third and perhaps most important part of this build, the preamp and USB interface.
Recuerda, la señal que sale de la cápsula del micrófono es muy débil, así que va a necesitar preamplificarse. Y una vez que esta señal es convertida de acústica a eléctrica, debe ser convertida a digital a través del convertidor analógico digital.
You see, although the signal from the microphone is strengthened by its transistor, it's still not powerful enough to actually send sound to the next stage, and needs some amplification. In a studio environment, this amplification is usually provided by a separate unit, available in many shapes and sizes for different use cases, but usually at a significant price tag.
Recuerda, con este proyecto de micrófono, preamplificador y convertidor analógico digital, no vas a necesitar más nada para hacer una grabación de voces.
As the plan is to keep everything self-contained and low cost, for us it means instead building one from scratch. In an effort to keep this simple for those of you who want to recreate this project at home, I've designed a preamp circuit that uses minimal components, so is fairly straightforward to put together, and in the description you'll find a PDF containing all the parts required and a strip board template that you can cut out.
En la descripción del video te dejo los diagramas para que puedas construirlo, pero también te voy a dejar el link del video original por si quieres visitarlo.
The idea with this template is to line it up with the holes on the strip board and stick it in place using some double-sided tape, poking through all of the holes with a pin as marked. Before adding any of the components though, we need to drill through the board at these outermost dots, which can be used later along with some PCB pillars for mounting purposes. And with that, we can begin. On the template, straight lines represent direct connections that must be bridged, of which there are 3. Next up are the resistors, although it's worth noting that some of their values have subsequently been updated since filming, so be sure to check out the template to be up to date. This process basically continues with some connectors, an IC holder and a few capacitors, all of which are clearly marked on the template. The last component to add here is a rather special one in the form of an isolated voltage booster, which takes an input voltage of 5 volts and boosts it up to not only 15 volts positive, but also 15 volts negative, which is important as that's what's required by the component that makes this whole thing work, a THAT 1512 integrated audio amplifier. This little beauty is essentially what does all of the amplification, taking the tiny signal from the microphone and boosting it up to a line-level output, all while contributing barely any noise at all to the circuit. Anyway, with this soldered up, it needs a housing to keep it safe. For aesthetics, I've decided to introduce some wood here, particularly as this piece has a really nice grain structure. Being wood though, it's not going to provide any interference protection, but this can quickly be remedied by adding some brass mesh and grounding it, though it's important to add an insulator between it and the preamp to prevent any short circuits. So with the preamp complete, the last thing to add here is a USB audio interface. From my experience, even cheap ones like this from Amazon can have a super clean input, as the circuitry they use has been around for years now, so it's fairly mature. Now the preamp itself needs to pull power from this Type-C connection as well, so I soldered up a couple of wires to its 5V output for this to be passed on. So with that done, it can be glued to the rear of the base, and the interface mounted wherever there's room for it, after which the audio cable can be plugged in, as well as the power cable, as shown here. However, how is it going to compare with something more expensive?
Si bien el diseño del micrófono es muy bonito, creo que no es funcional ya que es muy grande. Creo que esto se puede hacer con otro tipo de case o caja para que vaya directo a un stand de micrófono. Pero es algo que puedes cambiar si te animas a construir esto. Creo que la parte más importante de este video es cómo hizo la electrónica.
How is it going to compare against the king of microphones? That's right, this is a Neumann U87AI, a $3,000 microphone. That's 100 times as expensive as this. This is going to be interesting.
Pienso que una falla de este diseño es que no puedes instalarle un antipopper.
Testing, 1, 2, 3. This is with the Neumann U87AI, and it's one of the gold standard microphones and is used in studios throughout the world due to its natural sound quality and ability to be used with many different things like different instruments and stuff. And I'm going to switch over to my DIY microphone now so that you can get a general idea of the differences in the way these microphones render sound, and you can decide which one you prefer on my voice at the very least. I know this isn't a very conclusive test because with a microphone you would want to test it with different voices and different instruments and all sorts of things, but this is all I can do for now, and it just gives you a general idea.
Creo que la calidad de sonido del micrófono es muy buena y por $30 tener micrófono, preamplificador y interfaz de sonido, creo que es un precio ganador. Al ver el video, te adelanto que algunas partes no son tan fáciles. Vas a necesitar tener algún conocimiento para soldadura y ser hábil con las manos para poder construir algo que se vea estéticamente bien. Pero pienso que puede ser un proyecto de fin de semana que puedes disfrutar. Si este video te gustó, te invito a que vayas a la página del creador y le des un like.